Hello. In the previous example, you may have seen that the computations for using these unit step functions are a little bit tedious because it involves so much considerations. However, with some little modifications and use of some uh, relationships, we can simplify these computations. So let's see it with the help of one example. Okay, this example will also show you how to set up a function from the plot. So for example, if you have a plot of this function, so for example, this is 1, this is 2, so there is a function which changes, which is a constant at 2 until the value of t, which is equal to 2. So this axis shows t, and this axis shows the value of the function. Okay, so we have this function, and then there is a abrupt drop of this function to a value of -1, and then for the next number 3, this value then again rises to 0. So this is the function. Okay, 2 -1 and then 2. So this is 1, then that is 2, and this is 3. Okay, so first, then how can we represent this function f of t? Then we can start from 2, and then within bracket I can write 1 minus u t minus 2. Okay, and then the next function is -1. So I can put -1 times u of t minus 1 minus u of t minus 3. So this is u minus 2 minus u of t minus 3. Okay, and that's it. So because the next one is 0, so we don't need to put it over here. 0 will be 0. So we simplify it. So it is 2 minus, this is minus 2u, and then this is minus 1u, both are t minus 2, so it will be minus 3 ut minus 2, and then it will be plus ut minus 3. Okay, so in this way I can represent in this function in the unit step function format. So we can just verify it whether it works or not. So for first range of t values is from 1 to 2. So for any range of values between 0 to 2, not 1 to 2, 0 to 2, this step function will be 0. So only value remaining is 2. So that is correct. For any value of t between 2 and 3, so this last value will be 0. Okay, and ut minus 2 will be 1. So 2 minus 3 is -1. So this is -1. And for any value of t greater than 3, this is 1, this is 1. So 2 minus 3 times 1, 2 minus 3 is -1, -1 plus, and then this will be 1. Minus 3 plus 1 is 2 minus 3 plus 1, that is 2 minus 3, and then plus 1, that will be equal to 0. So we have verified that this type of representation of this function works. So if we want to find the Laplace of this function, we can very easily find it because I think earlier we have found that the Laplace of simply for the unit step function is actually e power minus as over s. So we can use this formula because in this case all the terms are not multiplied by any special function, only the constants are being multiplied. Okay, so here in this case we can simply apply this formula for finding the Laplace of this. So 2 is basically, so for 2 we can use this one. Laplace of 1 is 1 over s. Okay, so if for Laplace of 2 it will be 2 over s. So it will be 2 over s. So there is no unit step function involved over here. So 3 times u t minus 2, so 3 is a constant, so anyway constant will be multiplied with the Laplace, and then for this we can simply use this formula. So e power minus as, a is 2. So it will be minus 3 e power minus as over, sorry, a was 2, so minus 2s over s. And for the last one, it is simply ut minus 1, so it will be plus e power minus 3s over s. So this will be the Laplace transform. So therefore no need to consider any longer formula such which was this, okay, t minus a into u t minus a is equal to e power minus as times f of s. So we don't need to consider this formula. So this simple formula in this case will work. Okay. Okay. So next let's look at the some of the simplification for the inverse transforms. Okay. So let's see if we want to find the inverse Laplace transform of e power minus 2s over s minus 4. Okay, so this formula we can write in the form of the Laplace inverse transform. That means we take the Laplace inverse of e power minus as f of s, and then that will be equal to this function itself, f of t minus a into u of t minus a. Okay, so if I now compare this Laplace inverse problem with this, then I can see that e power minus 2s corresponds to e power minus as. So a will be equal to 2, and then f of s corresponds to everything else rather than this. So f of s will be 1 over s minus 4. So for this type of one of Laplace, I know that the Laplace of e power a t is equal to 1 over s minus a. Okay, we know this formula. Laplace of e power a t is equal to 1 over s minus a. So its Laplace inverse will be then, that means its corresponding function of t will be then e power minus 4t, e power minus 4t. Yeah, it should be plus 4t. Here we should be careful that these signs of a are opposite, so it should be e power 4t. Okay, so this will be f of t, but in our answer we need f of t minus a, not f of t. Okay, so our answer over here will be f of t minus a. So it means that t will be replaced with t minus a in this. So it was e power 4t, and t will be then replaced with t minus a. So it will be minus 2, 4t minus 2. Okay, and that was e power 4t minus 2. It is f of t minus a, and then times u of t minus a, so u of t minus 2. So this will be the Laplace inverse of this function. Okay, so let's take another one example. Laplace inverse of this e power minus pi by 2s over s square plus 9, and then also s over here. Okay, s over s square plus 9. So now if I compare it with this form of the formula, so a will be equal to pi over 2. Okay, a will be equal to pi over 2, and f of s is s over s square plus 9. So we know that the Laplace of cosine of omega t is equal to s over s square plus omega square. So therefore the corresponding function in t will be cosine of 3t, because omega is 3 in this case. Okay, this corresponds to. So, but the answer we need in f in terms of f of t minus pi. So t minus a. So in this case, a is pi by 2. So a is pi by 2. So it will be cosine of 3t minus pi by 2. 3t minus pi by 2 times u into t minus pi by 2. So this will be our answers. But we can further simplify this cosine term. So since we know that cosine of a minus b is equal to cosine of a cosine of b plus sine of a sine of b. So this formula from trigonometry we know. So we can apply this formula over here. Cosine of, so this is cosine of 3t minus 3 pi by 2. Okay, so it will be cosine of 3t cosine of 3 pi by 2 and plus sine of 3t sine of 3 pi by 2. So here we know that, here we can see that since cosine of 3 pi by 2 is 0, so this term will be 0, and sine of 3 pi by 2 is minus 1. Okay, so it will be minus sine 3t. So this will reduce, this term will reduce to minus sine 3t. So we can write it like minus sine 3t into u of t minus pi by 2 as our Laplace inverse of this function. Okay. Okay. Next, we can apply some further simplifications. For example, we have this formula Laplace of f of t minus a into u t minus a. So t shifting theorem. Okay. Okay. E power minus as into fs. So application of this t shifting theorem in this form is a little bit tedious because every time we have to convert this f function, which is in fact in the form of t, to f in the form of t minus a. So if somehow we don't have to convert this function in the form of t minus a, then it will give us very good alternative for solving the problems rather easily. So we say that we assume that f of t minus a is equal to another function g of t. Okay, and then we try to find the Laplace of g of t times u t minus a by the integration method. So 0 to infinity, it will be g of t u t minus a, and it has to be multiplied by e power st. Okay, and then dt. So by the integration we can find it like this. Okay, however this we can simplify it, because for any value of t less than a, this function is 0. So we can write it like this: from a to infinity e power minus st gt dt, because for between a and infinity the value of u will be 1. Okay. Okay. However, this form does not tell is not very useful for us at this moment, because we want to convert it into some sort of Laplace format. Okay. So what we can do is, because initially we assume that we can assume that u is equal to t minus a, okay, or t is equal to a plus u. Okay, and in this case dt will be equal to du. Okay, and we can also input these values over here. Okay, when we will input these values over here, so if for example t is equal to a, then t is equal to a, then u will be equal to 0. Okay, so the limits of integration will also change from 0 to infinity. So We will continue it in the next video.